Okay, so here we are in homework number 1 for Unit 3, and we're starting, this section of the course is problem solving, solving problems, word problems, tricky problems. Okay, so the first one says use Gauss's approach to find the following sum. And what that means, here's what Gauss did. Let's take this first one here, which is 1 plus 2 plus 3 plus 4 plus dot dot dot. 102 is the last one. Let me back up a little bit. Let me just go 99, 100, 101, 102, right? So I just want to show a few more at the end there, because then you can see Gauss's trick. Let me show you. Here's a guy named Gauss, Carl Friedrich Gauss, in the 1800s. He was like in 4th grade, and his teacher had all the students add the numbers 1 to 100 on their little slate boards, really, which takes forever. Well, the story goes like this. Gauss did a trick. He just said, well, look, I don't need to go all the way. What if I just take the first number plus the last number? 1 and 102. What are they total? 103, right? So he thought of this trick where you add the first number to the last number. Okay, now follow with me. We'll keep going here. Okay, and then he took the second number and he's going to add that to the second to last number. So what's 2 plus 101? It's also 103. And then the next rainbow, the third one with the third to last, 3 plus 100. What's that? 103. And 4 plus 99, what's 4 and 99? 103, etc. Do you see how they're all going to be 103 when you add this way, when you add with these rainbows, first and last, the first one and the last one, and then you do the inner rainbow, and you keep going. You're going to always have a total of 103. Okay, so what? Yeah, that's cute and everything. Well, actually, no, we can finish the problem now. We can figure out what all these numbers add to be super quick without going, one by one for the whole list. We can just say, look, how many of those rainbows are there? How many 103 rainbows are there? Well, every one of those rainbows uses 2 numbers, doesn't it? We have 102 total numbers. Divided by 2 equals 51 of these, I'll call them rainbows, connections. 51, how about I just say 51 groups of 2 numbers? 51 groups of 2 numbers. So we have 50, right? Because there's 102 total numbers. So if you break them into groups of 2s with these rainbow things, connect them up 2 at a time, divide by 2, you're going to have 51 total groups, right? So the total of all numbers is going to equal 51 groups of, what's each of those connections? 103, isn't it? It's 51 times 103, because there's 51 rainbows, 51 connections of 2 numbers, 51 groups of 2 numbers, and each of those groups of 2 numbers totals 103. So there's 51 times 103, which equals 52, 53. So that's the trick. Let's try the next one. Okay, so now for part B, it's similar but a little different. 1, 3, 5. Notice they're just odd numbers this time. They're not all the numbers, just the odds. So it's going to be like 97, 99, 101, 103 at the end. Right? I want to add up all those numbers, just the odd numbers. So let's do the same trick. Connect the first to the last. 1 plus 103. This time it's 104. And 3 plus 101, that's also 104. 5 plus 99, that's also 104, etc. So they're all going to be 104. But how many numbers are there? How many basically, let's say, how many odd numbers? 1 to 103. How many odd numbers? Well, basically, if you, half the numbers are odd, aren't they? So if you add, think about if you just took 1, 3, and 5. That's 3 odd numbers. If you just add 1 to the last number, get 6, and divide by 2, that'll give you 3 odd numbers. See what you need to do? You just got to take the last number, add 1 to make it even, and then you can divide it by 2 to find out there's 3 odd numbers. 1, 3, and 5 is 3 odd numbers. So let's do the same trick here. Take the last number, add 1 to the last number. You get 104. Okay, and then divide by 2, that would be 52. So that would mean there are 52 odd numbers. So there's 52 odd numbers. So what then? 52 odd numbers. So if there's 52 odd numbers, how many groups of 2 numbers are there? Well, half that. So 52 divided by 2, right? There's 52 odd numbers, but we're taking 2 odd numbers at a time in our grouping, right? We're always taking groups of 2 numbers. That would be 26 groups. So then the total equals 26 groups. And what's each group? 104, 104, 104. It's 26 groups of 104, which is 27. Oops. 04, 2704. Okay, here we are, number 2. Find the sum. This is another one of these add them up. Let's go to a fresh screen here for this one. So we're going to do starting at 38 all the way to 121. 38. We're just going up by 1. Dot, dot, dot. Let me see. The last one's 121. So I'm going to, if it's 121, I'm going to back up a couple. 120, 119, just to give the same number in the beginning and the end. Make it easy to do the Gauss trick. So here we go. Make a big arc here. What is it? I don't know. What's 121 and 138? If you add these numbers up, use your calculator. What is it? 159? Yeah, 159. And then these two. What do they have to be? 159. And then these two, 159, etc. So they're all 159. That's the trick Gauss noticed when you do these little arc rainbow things. You get the same answer all the time. So, but how many numbers from 38 to 121? And then we got to cut that in half because we're taking them in groups of 2. So first off, how many numbers from 38 to 121? Well, if you think about it this way, 1 to 37 are missing, right? Numbers 1 through 37 are missing. So aren't there 120? Whoops, getting kind of scribbly there. So doesn't that leave us with 121 numbers minus the 37 that are missing, right? Because from 1 to 121 would be 121 numbers, but the first 37 are missing. So subtract that. What do you get? Is it 84, I think? Trouble with my pen here. 84. 110, 11, 12. Yeah, that's right, 84. So there's 84 numbers, but then we got to take the 84 and divide by 2, which is 42. Because why? Because they're in groups of 2. Groups of 2 numbers. Right? There's 42 groups of 2 numbers. So the total then of all those numbers is 42 groups, and each group is 159, 159, 159. 42 times 159, which is 6678. So we just added up all those numbers that quick with the trick. That's a problem-solving trick. We're learning a way to solve tricky problems. Okay, so number 3. This is a different kind of problem. Cookies are sold singly, one at a time. You can buy just one cookie, or in packages of 8 or 24. With this kind of packaging, how many ways can you buy 48 cookies? That's a strange question, isn't it? So let me help. Let me go to a fresh screen here. So problem number 3, you can buy 1, 8, or 24 cookies in a package. 1, 8, or 24. And at a time, right? There's a package, you can buy just one, or there's a package with 8, or there's a package with 24. How many ways to buy 48? How many ways? Oh, my pen's having trouble here. How many ways to buy 48? So what are we talking about? Well, here's one way. Here's way number 1. Let's start with the biggest thing we could get. We could buy a package of 24 and a package of 24. That's one way to get 48 cookies. A package of 24 and another package of 24. Here's a second way. You could buy a package of 24, and instead of another package of 24, you could buy 3 packages of 8, right? Because that's 24 and 24. That's also 48 cookies. That's a different way to buy 48 cookies. Here's a third way. You could buy 24 and 8 and 8, and instead of buying those last 8, you could buy 1, 2, 3, 4, 5, 6, 7, 8 singles. Let me just write 8 singles. Man, is that confusing? Because this is a package of 8, 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 and this is 8 singles. That's still, 24 cookies, and 3 times 8 is 24 cookies. That's 48 cookies. That's a different way to buy 48 cookies. Let's try a fourth way. Start with 24, package of 8, and then 8 singles here, and 8 singles there. See how that's a little different? Now there's 16 singles. 1 package of 8 and 24. That's another way to get 48 cookies. Do you see the pattern? I'm starting with 24 again. And now we could do 8 singles for all 3. 8 singles, 8 singles, 8 singles. So that's 48 cookies again, isn't it? So do you see the pattern? We had 3 packages of 8, 2 packages of 8, and 8 singles, 1 package of 8 and 2 groups of singles, and then all 3 groups of singles. Okay, so those are all the ways where you start with 1 package of 24, aren't they? Now, number 6, 6th way, instead of starting with that 1 package of 24, you could start with a package of 8, a package of 8, a package of 8, and where could we go from here? We could do all packages of 8, couldn't we? 6 packages of 8. Is that making sense? 6 packages of 8. So I'm trying to be systematic about this. I'm trying to have, because I don't want to, this is how you make sure you don't miss any. You have a system. So my system is start with the biggest you possibly can, 24 and 24. Biggest packages. Always start with the biggest packages possible. Then all the way down the line, I keep starting with that package of 24, and then I broke the other 24 down to 3/8, and then I broke the last 8 down to singles, then the last 2 8s down to singles, then all 3 8s down to singles. Always starting with a package of 24. Now I can't, that's all I can do starting with a package of 24. Now I'm not going to have any packages of 24. I'm going to just start with packages of 8 and do 6 packages of 8. And then number 7, I'm going to have a package of 8, and do the big packages as long as I can. Package of 8, package of 8, and the last one, 8 singles. So the last package of 8 becomes 8 singles. And you get what I'm going to do now, huh? Package of 8, package of 8, package of 8. Remember, I can't do any packages of 24. I've done all of those right here. These are all the ones involving 1 or 2 packages of 24. So now I've just got to break 8 singles, 8 singles. Both of these last 2 become 8 singles. Number 9, package of 8, package of 8, package of 8. Now the last 3, 8 singles, 8 singles, and 8 singles. The last 3 groups are all singles. Now number 10, package of 8, package of 8. Now the last 4, 8 singles, 8 singles, 8 singles, 8 singles. Number 11, package of 8. And the last 5 are all singles. 8 singles, 8 singles, 8 singles, 8 singles, 8 singles. And finally, number 12, they're all singles. No packages of 8. All singles. All the way. 48 single cookies. There's 12. That was the 12th. 12 different ways. How many ways to buy 48 cookies? There's 12 ways. 12 different ways you could get your 48 cookies based upon the 3 types of packages: single, 8 in a package, or 24 in a package. Those are all 12 different ways. And I know I've got them all. I know I haven't missed any because I used a system starting with the biggest possible and finally going all the way down to 8 singles 6 times, 48 individual cookies. 12 different ways. So that's called, that technique I just did there is called making a systematic list. That's a systematic list. I used a system. I started with the biggest packages down to smallest. That was my system. Now, you don't have to start with a system. You can start with the smallest packages and go up to the biggest, whatever. Just don't do it randomly. Have a system. That way, you know you haven't missed any, because that's the key, that you don't even miss one possibility, that you get all 12 different ways. If you just randomly just write down whatever comes to your mind, not using a system, you're going to certainly miss a couple. So if you have a system, start with the biggest, go to the smallest packaging, or vice versa, or some other system. As long as it's a system, you'll get them all, as long as you're careful to follow your system. That just takes practice. Okay, so let's go to the next one. So here we are with number 4. Without computing each sum, find which is greater, O or E, and by how much. This is the O stands for odd numbers, E stands for even numbers. So which one of those lists do you think is bigger? Can you see that the E list is always bigger than the O list by 3? Right? This is 3 higher. 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 See how the bottom list is always 3 higher? So the O list, the E list, the bottom one, the E list is greater than the O list. So that's the greater list. The E is greater. And by how much? So the E is greater. But how much? Now we can't just say by 3. Every number in the list is bigger by 3. Every number, right? This is add 3, add 3. Add 3, add 3, add 3. The bottom list is bigger than the top. Every number's bigger by 3. So basically we have to figure out how many numbers in the lists and then multiply that by 3, because every number is bigger by 3 in the bottom list. So how many numbers are there? Well, look at this top one. How many numbers? 1 to 101 odd. Remember how we figured out how many numbers? Because half the numbers are odd, right? So if you just add 1 to this and get 102 and divide by 2, that'll be 51 odd numbers. So there's 51 odd numbers between 1 and 101. So there's 51 odd numbers. Okay, so what? And that means there's also 51 numbers in the bottom list because they match up 1 for 1. So there's 51 numbers in each list, and every number in the E list, the bottom list, is 3 bigger. So how much bigger is the bottom list? It's 3 bigger for each number times 51 numbers equals 153. It's bigger by 153. If you added up all of the E numbers and added up all of the O numbers, the E list would be greater by 153 because every one of its 51 numbers is bigger by 3. So that's 153 bigger. His total adding up, his sum, his adding up total would be bigger by 153. Okay, so number 5 here. Kyle, Carrie, Mona, and Sulin are in a horse race. Carrie is the slowest. Mona is faster than Sulin, but slower than Kyle. Name the finishing order of the horses from last place to first. So let's start with last, first, and let's just simply be careful and follow the words. Carrie is the slowest, so Carrie's over here in last place, right? This will be second place, third place. So Carrie, last place, slowest. Mona is faster than Sulin, but slower than Kyle. So Mona is faster. So Sulin has to go behind Mona. Mona is faster than Sulin, but Mona is slower than Kyle. Kyle has to go ahead of Mona because Mona is faster than Sulin, but slower than Kyle. So this must be Kyle here in first, Mona in second, Sulin in third. Must be like that. So Carrie, Sulin, Mona, Kyle, right there. Answer C. Okay, so number 6, shown on the right, magic square, which means all rows, columns, and diagonals sum to the same number. Find the value of each letter. So that means like whatever these 3 add up to be is the same total that these 3 add up to be, that these 3, that these 3, that these 3, that even the diagonal and that diagonal, all the diagonals, all the rows and columns total the same thing. So with that in mind, we should be able to find A, B, C, and D. How so? Well, I don't know. Let me see. Let's try to look. Let's look for some. Is there somewhere where we have all numbers? Oh, yeah, right here. Look at that diagonal. So 7 plus 16 plus 25. Just numbers, no letters, so I can add those up. What is that? 31, 41, 48. So that must be the total of every row, every column. They almost total 48. So, for example, I can get A now because I know 7 plus A plus 18 must be 48. How do I know that? Because all the columns and diagonals and rows all are the same total. And now I know the total, 48, because I had that one diagonal with all numbers. So what does that mean? A plus 25 is 48. 18 and 7 is 25. Subtract 25. So A is, what's that, 23. So A must be 23. Let me erase here. Let me erase this stuff and put in. I now know A is 23. Can I, whoops, getting kind of scribbly there. Can I get B now? Where's B? Yeah, these 3 for B. So 27, 16, and B must also make 48. What's that? 27, 16, 33, 40, 43, whoops. 43 plus B. 48, subtract 43. B must be 5. So B must be 5 to make that row 48. Because they're all 48, we know. All right, C and D. To get C, I'm not going to go sideways because that would be 2 letters. I don't know C, I don't know D. I couldn't solve that. But instead, you see what I can do? Go vertical. So 7 plus 27 plus C must be 48. What's that? 27 and 7. 34 plus C is 48. So C must equal subtracting, what is that, 14? So C must be 14. And finally, D. D I can get, sideways or straight down, whatever. 23 plus 16 plus D is 48. What do these two make? 39. 39 plus D is 48. Subtract the 39. What's that? 9. D must be 9. Yep, D must be 9. Found them all, A, B, C, and D. Okay, this one can be tricky. It says the 14 digits of a credit card are written in the box as shown. If the sum, see what it says right here. My pen's not writing very well. So if the sum of any 3 consecutive digits is 12. So any 3 consecutive digits in a row is 12. So you add up 3 digits in a row, it's 12. So what that means is these 3 digits in a row must add up to 12. So 6 and 4 is 10, so this must be 2. So those 3 digits now make 12, don't they? And okay, so you see how I found that 2? That must be a 2, because 6 and 4 is 10, and then 2 is 12. And they said any 3 consecutive in a row, any 3 digits in a row, the sum is 12. Okay, great. So that's how we get that. But how are we going to get all the way down here and find A? Do you see what we could do? Do you see the trick? If I now move to these 3 digits, they also have to make 12. Right? Because it said any 3 consecutive digits is 12. So those 3 have to make 12 also. How are they going to do that? 6 and 2 is 8. And 4 makes 12. That has to be a 4 for those 3 to make 12. And then we just keep going. You get it? Let me erase this here. That's 4, and that was 2. I don't want to forget what we had. It's 4, and that's 2. Okay. So now these 3 digits must make 12. So 6 and 4 is 10, and 2 is 12. And then we just keep walking to the left. Next group. These 3 digits must make 12. Because any 3 digits in a row always makes 12. So 4 and 2 make 6, and 6 makes 12. Keep going. Next, we say, well, these 3 digits must make 12. That's a 4 there. So 6 and 2 makes 8, and 4 makes 12. So are you seeing the pattern here? So 6, 2, 4, 6, 2, 4. We can just save some time. 6, 2, 4. 6, 2, 4. That good? See the pattern? Just 6, 2, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4. Okay, now how do we keep going? Well, same way. So these 3 digits must make 12. 6 and 2 is 8, and 4 is 12. Now, finally, we're in position. Put this back. This is a 4. We're in position to finish this problem. These 3 must make 12. A plus 4 plus 6 must be 12. So this is 10, so A must be 2. A is 2. Or we could have just continued the 6, 2, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4, and this must be 2, 4 because the 6 would come next. However you want to think about it, A's got to be 2. All right, Kathy stood on the middle rung of a ladder. She climbed up 2 rungs, moved down 4, climbed up 9, then climbed up the remaining 3 to the top. How many rungs in the whole ladder? That's confusing. How are we going to do that? Let me bring it down here. Let me do this. It's all about just the technique, the problem-solving technique on this one is just drawing a good diagram. Let me start right down here and say this is the middle rung on the ladder. She stood on the middle rung, right? Okay, what'd she do next? Then she went up 2 rungs. So up 1, 2. Right, I'll put a Kathy. She's there right now on that rung. Then she moved down 4 rungs. So from here I'll go down 1, 2, 3, 4. There's got to be a 3 and a 4. So she went down 4. Now Kathy, whoop, my lines aren't getting so good there. Kathy's right here on this one, right? She went down 4 rungs, down 4, then climbed up 9 rungs. Now I'm going to go up 9 rungs. I'm going to try to get rid of some of this. She's going to go up 9 now, starting from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now she's up there. That was up 9 rungs. Finally, last step in the problem, she climbed up the remaining 3 rungs, up 3. 1, 2, 3, 1, 2, 3. Kathy ended up there. To the top. That's the top. This one up here is the top. There's 3 purples. Then the top purple one is the top. So that's the top. So now we are ready to answer the question, which is how many rungs in the whole ladder? How many rungs in the whole ladder? Well, look, can we count all of these? Because they're above the middle. And if we figure out how many are above the middle, it's got to be the same amount below the middle. That's what makes the middle the middle. We can figure out the total. How many above the middle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 above the middle. 10. So 10 above, 1 in the middle, and 10 below, because otherwise it wouldn't be the middle if it didn't have the same amount above and below. Add them up, 21 rungs on the ladder. See how we got that by a good picture? One winter night, number 9 here. One winter night, the temperature fell 9 degrees between midnight and 5 a.m. By 9 a.m., the temperature had doubled from what it was at 5 a.m. By noon, it had risen another 8 degrees to 36. What was the temperature at midnight? Okay, well, let's try to draw this out really carefully. So the temp, so whatever the temp was, so there was the original temp, okay. One winter night temp fell 12 degrees between, so there was we start at midnight, I guess. Okay, so we have the temp at midnight, and then it's the temp minus 12 at 5 a.m. So, or let's call it M. How about we'll call M the midnight temperature, and this will be M minus 12. Right, M is the midnight temperature, and then it fell 9 degrees between midnight and 5 a.m. So by 5 a.m. it was M minus 12. By 9 a.m., just going from 5 a.m. to 9 a.m. now, from 5 a.m. to 9 a.m., the temperature had doubled from what it was at 5 a.m. It's doubled, so it's 2 M minus 12. It's double what it was at 5 a.m. And then by noon, at noon, it had risen another 8 degrees. So it's 2 M minus 12 plus 8. I'm kind of running out of room. Plus 8 at noon. At noon it went up another 8 to 36 degrees. This equals 36, so it's a little equation. This equals 36. So bring this up here. We have 2 M minus 12 plus 8 must equal 36 degrees. because they told me 36 degrees at noon. So solve that equation for m. Subtract 8. I'll distribute this here. 2m minus 24. 36 minus 8, what's that? 28? Yeah, and then add the 24 over. Gonzo, 2m is, what's that? 40, 52. Last step to solve for m, divided by 2. So m equals, what's that? 26. At midnight, temperature must have been 26. All right, number 10 is last here. 4 people come to a party and shake hands with each other. If each person shakes the hand of every other person, how many handshakes occur? Well, I don't know. So let's talk about the first person. There's 4 people at the party. So the first person shakes the hands of person 3, 2, and 1. Well, he is person 1. He's person 1. So person 1 shakes the hands of, whoops, I'm getting confused. Shakes the hands of persons number 2, 3, and 4. And then person 2, he shakes 1, 3, and 4. But wait a minute, we've already counted 1 shaking 2 right there. So I don't need to say 2 shakes 1. We've already counted their handshakes, so I don't need to list that. So the only new handshakes for person 2 is shaking hands with 3 and 4, because we've already counted 2 and 1 right there. And then person 3 shakes hands with 1, 2, and 4, but we've already counted 1 and 2, because person 3 shook hands with person 1 there, and 2 with 3 there. So we don't need to recount that. So we just have to count 3 with 4. And then we come to person 4, they're all done. We've already got them right there with person 1, with person 2, and with person 3. So there's no new handshakes to count. So how many total handshakes do we have? 1, 2, 3, 4, 5, 6. 6 handshakes. And there we go.